Good morning, Nana. So, combinations chapter we are doing. Combinations. Okay, yesterday we learned some formulas on the combination. What is the combination means? Selection of things, and it is selection, it is a selection that the number of ways of selecting out of any dissimilar things taken or at a time, it is denoted by NCR. So that is the formula is NCR equal to n factorial by n minus r factorial into r factorial. Okay. And then relation between the NPR and NCR we learn, that is NCR equal to, okay, Nirali. NCR equal to NPR by R factorial, and the sum of the product of the first n natural numbers decreasing from n by denominator R factorial means the product of the first n natural numbers. Okay, NCR is always exist only for R is less than or equal to n, that is the value, and it gives only the always it is to positive integer, and nc0 equal to what? nc0, nc1, nc0 equal to 1, nc1 is decreasing from n, starting with n decreasing up to n terms, divided by denominator 1 factorial, nothing but n. nc2 equal to n into n minus 1 by 2 factorial, and next nc3 n into n minus 1 into n minus 2 into n minus 3 by 3 factorial. Okay, next one, similarly we can write as NCR equal to n into n minus 1 into NCR equal to n into n minus 1 into n minus 2 into so on n minus 3, starting with n writing up to r terms, that is n minus of r minus 1 divided by r factorial, nothing but 1 into the product of the first n natural number, that is 1 into 2 into so up to r terms. So that is and r factorial. The basic formula is n factorial by n minus r factorial into r factorial. R, otherwise NCR can be written as NPR by r factorial. NPR nothing but this one. N into n minus 1 into n minus 2 into so on up to rth term, that is n minus r minus 1 by r factorial means 1 into 2 in the product of the first natural numbers, that is 1 into 2 into 3 so on up to r. And the next relation is the basic formulas we have learned, that is NCR is always equal to NC n minus R. Next, suppose 10C3 is equal to 10C7. 10C 10 minus 3, that is 10C7. 10C7 value, whatever the value we got, that is also equal to 10C3 also same by using this condition. NCR equal to NC n minus R. Next one, NCR plus NCR minus 1. NCR plus NCR minus 1 gives us to N plus 1 CR. So this is the most important formula for objective. Next one, NCR minus 2, write formulas, Nana, daily you can write, then you get the answers very easily. And then 2 into NCR minus 1 plus NCR equal to n plus 2 CR. NCR minus 2 plus 2 times of NCR minus 1 plus NCR equal to n plus 2 CR. And then the next basic formula, NCR equal to NCS, then the value is becomes to R equal to S, or N equal to R plus S. This is the basic formula. The condition, this is the value for this. And then go to the some objective questions on today. Most important objective questions. Please inform to your friends. So some people are coming. What about the remaining? What about the remaining, Nana? Nishan, where is Nishita? Amulya, Bhuvan, Nirali. Only 12 members are present. What about the remaining, Nana? Sorry, today we'll start some objective points. Write down the formula, most important formula. So we are doing some short trick, that is beggar's method. Using the formula name, I am keeping like that, beggar's method. Okay, Nana, Nishita, okay. The beggar's method is the objective mains and advanced level question. The basic formula, what is the formula? First we have to write beggar's method. Formula is the total number of ways of dividing some in different in identical items among our persons, in which we can receive 0, 1, 2 more times, that is denoted by n plus r minus 1 or n plus p minus 1 cp minus 1. Now, okay, write down the formula, beggar's method. One question in the mains question compulsory, the number of ways of distributing n identical things. The things are all are identical. Okay, and identical things among p person, total persons are p, among p persons without any restriction, that means it has to be given as none or one or two or all or any number of things can be given to one person. That is n plus p minus 1 cp minus 1. This is the formula. So we have n identical things among p persons. We are giving to without any condition or give as to the any number of coins or things or any objects, any without any restriction, we can be given to the person by none or one or two or all of any number of things can be given to a one person. The condition is the value is n plus p minus 1 cp minus 1. This formula we can simplify as our convenience. The name is like that, beggar's method. Beggar can give any, if you want to give any, that beggar can you give 0 points or 1 coin or 2 coins or anything or all as your wish. Similarly here totally n identical things are there without among p persons without any condition can be given to the one person. The formula is n plus p minus 1 cp minus 1. Okay, first write down the next simple method formulas and see the n distribution of things. Heading as to distribution of things, distribution of alike objects, distribution of alike objects, the method, but we are keeping our convenience beggar's method. Beggar can achieve any value taking the 1 or nothing, and 1 or 2 or all of any number of things can be given to the person. That is why I kept as the name as beggar's method. So our convenience, okay, that is meaning that distribution of alike things, the formula is n plus p cp minus 1. That is n plus p minus 1 cp minus 1. C means combinations are giving out of n plus p minus 1 or cp minus 1. So, and the next second formula is dividing n identical items into r persons such that, okay, Mallika, such that each person gets at least one item is, only one item is nothing but n minus 1 C P minus 1. Okay, first write the formulas. Okay, next what is the formula? Number of ways of values achieving taking identical things into r persons dividing n identical items into r persons such that each person gets at least at least one item is, it is nothing but at least one item, nothing but in the place of p value we have to kept as to 0, then it is n minus 1 c. Suppose p persons are there, we can write n minus 1 p minus 1. So at least one item. Here none or one or two all are there. So n plus p minus 1 cp minus 1. Here at least one item means you can give one or two or more or. So 0 is not included. That is why this is the value n minus 1 cp minus 1. Based on these formulas we can name it as beggar's formula. So okay. Based on this question, all previous PYQs, that is previous year questions, as means. So write down the first question. Number of ways in which 21 rupee coins can be distributed among 5 people such that each person gets at least 3 rupees each. So the question is the number of ways in which 21 rupee coins, 20 coins number is 20, 1 rupee coins, denomination is 1 rupee coins, can be distributed among 5 people such that each person, yes, continuation classwork, all those problems and the based on permutation combination means all those write in the classwork only. Please inform to your friends, all our most important topic is going on now. So please inform to your friends. Each person gets at least 3 rupees is dash. Options are 126, 63, 125 and then none. By using the beggar's formula, the problem is goes to simplification. By the formula we can apply n plus p minus 1 cp minus 1. We have to write our problem, our convenience by using the shortcut beggar's method. Number of coins are 20 coins and number of persons are 5 people. Then the let it be, we can take the 5 persons as to P1, P2, P3, P4 and P5. So the question is given that each person gets at least 3 rupees. So I am giving the person as as to 3 rupees, and the second one as 3 rupees, and then 3 rupees. At least 3 means starting with 3. Then how many rupees we can? 3 into 5, 15 rupees over. Then totally we have 20 rupees. So 20 minus 15. So the remaining object are, therefore remaining things how many rupees? Remaining coins is equal to 5 coins. Then that implies P1 plus P2 plus P3 plus P4 plus P5 equal to, can be distributed by remaining 5% equal to 5. That is, the formula is n plus p minus 1 cp minus 1. That is n equal to how many members? N equal to nothing but persons. Persons is equal to n equal to 5, and coins also remaining 5 coins. 5 plus 5 minus 1 c 5 minus 1, that is total value is 9c4. 9c4 nothing but 9 into 8 into 7 into 6 5, 4 into 3 into 2 into 1, 4 2 is 8, 3 3 is 9. So that is 126. Then go to the option number 126. So this is the question. This carries PYQ problem in previous 2019 question. That is, Beggar's formula can be easily write the formula, Beggar's formula, then we can get the answer very fast. But we write all those conditions, so much time it's taken time. But using the Beggar's formula, persons are P1, P2, P3, P4, P5 are there. So each person get at least 3 rupees, means I am giving to the person each by 533 rupees. Totally we have completed distributed as 15 rupees. In these 15 rupees, remaining money is, remaining coins are 5 coins. So the distribution can be applied by P1 plus P2 plus P3 plus P4 plus P5 equal to 5. This can be distributed, at least the remaining money can be distributed as by using the formula n plus p minus 1 cp minus 1, that is number of persons are 5, remaining 5 rupees substituted, then you get the answer as 126. Nana Shenmukha is there. Shenmukha, Anirudh, Lohit. Please inform to them. Okay, next question, same similar concept. Last year previous questions all are. Write down the next question. Find the number of ways. Find the number of ways in which 16 identical. Please inform to your friend. These are all easiest shortcuts by using the formula by solving the Beggar's method. Formula is n plus p minus 1 cp minus 1. So all are important. Please inform to your friends. 16 identical things can be distributed among four persons if each person each person gets at least three things. These are all PYQ, nothing but previous year questions. Okay, by using the Beggar's formula, distribution of alike objects, that is, question is find the number of ways in which 16 identical things can be distributed among 4 persons if each person get at least 3 things. So how many we have? Totally persons are 4 persons. So distributed to the identical things as to 16 identical things. So let it be P1 plus P2 plus P3 plus P4. So persons are 4. How much money? P1, P2, P3 and then P4. Each person get at least 3 means 3 rupees again. The leftover money is 4 into 3, 12. We have the 16. 16 minus 12 nothing but 4. Therefore, by remaining equal to 4. Therefore, P1 plus P2 plus P3 plus P4 equal to 4. By using the Beggar's formula, N plus P minus 1 Cp minus 1, which is equal to N equal to how much? 4% and 4 remaining money minus 1 C4 minus 1. So that is equal to 7C3, which is equal to 7 into 6 into 5 by 3 into 2 into 1. So 7 5 is 35. Options are given as 36, 38, 40, 35. Then go to the option number 35. Okay, this is the formula. By using the shortcut formulas, Beggar's formula, then we can get the answers very easily within 1 minute. Okay, find the number of ways in which 16 identical things can be distributed among 4 persons. Identical means all those. If each person gets at least 3 things, means persons can be given to the 4 persons. Remaining things are 4. So make it to distribution by the using the formula N plus P minus 1 Cp minus 1. So remaining money is 4 persons are N equal to 4%. Remaining money is 4. So 4 plus 4 minus 1 C4 minus 1. Okay, then the value is 7C3, that is equal to 35. Okay, option number D. Okay, next Achilles. Where is Achilles? Lohit. Similar concept question remaining. Another one is there. So many problems are all are previous year questions only. Question number 3. Find the number of distinct throws which can be thrown with n six-faced dice which are indistinguishable among themselves. Okay, this is also previous Q. Find the number of distinct throws which can be thrown with n six-faced dice which are indistinguishable among themselves. Find the number of ways distinct throws which can be thrown with n six-faced normal die which are indistinguishable among themselves is dash. The question is like this. So that is, first write down the meaning of indistinguishable means what? The meaning is what? That is meaning identical, which are identical among themselves. Number of persons are not given. So number of persons, six-faced dice is given. So let it be x1 plus x2 plus x3 plus x4 plus x5 plus x6 equal to n. Number of persons equal to n. By using the formula n plus how many? N plus 6 minus 1 C6 minus 1, that is n plus 5 C5. Options are given n plus 2 C5, n plus 3 C5, n plus 4 C5, n plus 5 C5. So option number D, this is also. So number of distinct throws, that is six-faced die which are indistinguishable among themselves is n plus 5 C5 things. Okay, next question, question number 4. If A comma B comma C comma D are odd natural numbers such that A plus B plus C plus D equal to 20, then find the number of values of the ordered quadruplet is dash. If A comma B comma C comma D are odd natural numbers such that A plus B plus C plus D equal to 20, then find the number of values of the ordered quadruplet is dash. What is meaning by quadruplet? Anybody knows? This quadruplet means what is the meanings? Different words are in the give questions. Wordings are different are there. Yes, quadruplet means ordered pair means what? Ordered pair means two terms. Okay. Ordered pair is A comma B. Next, triplet means A comma B comma C. Okay. Next, quadruplet means A comma B comma C comma D. Ordered pair means only two numbers are there. Triplet means A comma B comma C in the ordered form. Quadruplet means A, B, C, D. Okay. This is the value. Then the value is given for odd natural numbers such that the condition is A plus B plus C plus D equal to 20. Then find the number of values of ordered pair of the quadruplet. So first write down, let the odd natural numbers always of the form, let it be A equal to, let it be 2m plus 1 and then 2n plus 1 and suppose T equal to 2p plus 1 and then D equal to 2q plus 1. But in the question is given that what? A plus B plus C plus D equal to what? 20 is given. Now the values goes to 2m plus 1, 2n plus 1, 2p plus 1 and then 2q plus 1 equal to 20. From these two common, m plus n plus p plus q equal to 1, 1, 1, 1, 4. 20 minus 4 equal to 16. Then the values goes to m plus n plus p plus q equal to 8. Now it is looking like as a distributed of 8 things among 4 people. So that is it is similar to, it is distributed 8 identical things among how many persons? 4 persons. Therefore, the formula using the Beggar's formula, that is 8 plus 4 minus 1 C 4 minus 1, which is equal to 11C3. Options are 11C3, 10C3, 9C3, 12C3. So 11C3 is the answer. Okay, all are understood all these problems. One question in the examination. Okay, give the response. Are you getting or not? Okay, need the next question, question number 5. Find the number of integral solutions of the equation. Find the number of integral solutions of the equation x plus y plus z equal to 10 is dash. So that is, how many are there? X plus y plus z equal to 10. Sorry. Number of solutions in the equation, just formula n plus p minus 1 cp minus 1, that is Becker's formula. N equal to, total things are 10 and p is nothing but 1 2 3, then 10 plus 3 minus 1 c 3 minus 1, then it is get as 2 12c2. Options are given 10c2, 12c2 and 11c2 and then 9c2. So option number B. N equal to, total value is 10. P means distributed persons are 3 persons. So then 10 plus 3 minus 1 C 3 minus 1, that is 12C2. Same similar question it is in the form like this only, it is also another question is given. Find the non-negative integral solutions. Non-negative integral solutions of x plus y plus z equal to 10 is given dash. So we need two separators. If they given as positive means 0 is not included. Non-negative is given means 0 will not be given to. So then the formula is goes to n minus 1 cp minus 1, then 10 minus 1 c3 minus 1, that is equal to 9c2. Okay. So non-negative integral solution means 10. If 0 is not included, then the formula is n minus 1 cp minus 1. That is the form 10. So persons are 3, 10 minus 1. Persons are 3 persons. That is 3 minus 1. That is equal to 9c2. Okay. This is the question. All are PYQs. Okay. Next question. Question number. How much Nana? Question number 5, 6 question. The number of ways of distributing 10 identical balls in the 4 distinct boxes such that no box is empty is dash. The number of ways of distributing, 10 identical balls, 10 identical balls in 4 distinct boxes such that no box is empty is dash. So the number of ways of 10 identical balls are there, 4 distinct boxes such that no box is empty. So box should be empty means no box is given. So 0 is excluded. Therefore the formula is goes to n minus 1 c p minus 1. N equal to how much? 0 is not equal to means 10 things, minus 1 c 4 minus 1, that is equal to 9c3. That's all. The both boxes, no box is empty means 0 is excluded. Therefore, the formula is goes to n minus r n minus p minus 1 formula can be goes to the value as n minus 1 c p minus 1. Okay. Next question number 7. The number of ways of distributing 8 identical balls in three distinct boxes so that none of the box is empty. None of the box is empty. Is dash. Here also none of the box is empty. Give the response, Nana. Answer give. Give the response. What is the answer? Shanmuka, Amulya, Nirali, Bhuvan, Nishan. What is the answer for this question? Here, find the number of ways of distributing 8 identical boxes in the 3 distinct boxes so that none of the box is empty. Ramesh, Shashank, Nishita, Nirali, Nishan. Yes, 7. No. 7. No. Observe once again. None of the box is empty. The formula goes to n minus 1 Cp minus 1. Yes, Pranav Sagar, okay. That is okay. 7, 8 minus 1, C, 3 minus 1. That is 7C2 only. Okay. 7C2. The question is 7C2. Nishan. Yes, correct. Next question. None of the box is empty. This is the most previous year question only. Think and write. The total number of positive solutions. The total number of positive integral solutions of solutions 15, x1 plus x2 plus x3 lesser than or equal to 20 is k. Then the value of k by 100 is equal to dash. The question is like that. The question is like that. The total number of positive solutions of the condition is x1 plus x2 plus x3 is lies in the interval 52 or equal to 20 is k. Then the value of k by 100 is dash. Pranav Sagar, are you getting, Nana? Where is Lohit? Akhilesh? So the condition is given, positive integral solutions are given. So then it is goes to write x1 plus x2 plus x3 so on up to that is equal to or equal to 20. 15 to 20 is given. So that is meaning that lies in the interval starting with 15, no, starting with 16 or 17 or 18 or 19 or 20 will also is there or not? Okay, it is or equal to given that equal to given. So 20 also included. Therefore, the condition is goes to x1 plus x2 plus x3 is equal to 16 plus value something p. This is 16 Nana. 16 plus some p where p equal to 0, 1, 2, 3, 4. 16 plus 0 means 16. 16 plus 1 is 17, 18, 19, 20 like that. Therefore, the relation is goes to x1 plus x2 plus x3 equal to 16 plus p. Now think over the distributions are n equal to here what? N equal to 16 plus p. Number of persons are persons equal to how many? X1 plus x2 plus x3. This can be distributed as 16 plus p things can be distributed among 3 persons. Now it is goes to the formula by Beggar's formula 16 plus p minus 1 c 3 minus 1. Then it is goes to 15 plus p c2. 15 plus p c2. Now write as 15 plus p is p equal to 0, 1 write first one. So then you get 15 plus p nothing but 15 c2 plus 16 p plus 1 means 16 c2, 17 c2, 18 c2 and then 19 c2. 15 C2 nothing but 15 into 14 by 2 into 1. 16 C2 nothing but 16 into 15 by 2 into 1. So first we are doing simplification if any value will get observed. Okay, here 15 is common. Then cancelling 7. Here 10 cancelling 7. 15 is common means 17 plus 8. That is means 15 into 15, 15 square for this value. Similarly, this total terms can be write as to then you get 16 square. No, 16, not 16 plus 17 into nothing but this value goes to 17 square. And this value is nothing but 19 into 18 by 2 into 1. So that is 19 into 9. So that is 171. So total value becomes to 225 plus 17 289 plus 171. The values goes to 685. The options is correct. So that is the value. So whatever the value condition is given, like this questions also you have to practice. 6 x1 plus x2 plus x3 is equal to 16 or 17 or 18 or 20. Then it is goes to 16 plus p I have taken. Now it is in the form of among n person can be distributed three form. 3 persons can be arranged in 0 or 1 or 2 or 3 or 4. So now by using the Beggar's formula n plus p minus 1 cp minus 1. In this Beggar's formula n equal to in the form 16 plus p is there. R equal to nothing but P equal to number of persons equal to 3. Now we can get 15 plus P C2. 15 plus P C2 things. 15 plus P2 C2 nothing but 15 C2 plus 16 C2 plus 17 C2 plus 18 C2 up to 19 C2. By calculating the first two terms, we can get 15 into 7 plus 8. Here 7 plus 8, that is 15 square. Similarly, this term we can get as 17 square. This is obviously 19 into 9. Total things we can get as 685. Okay, this is the option. Question number this. Okay, simplify. Like these questions are giving in the examination. Next question. Find the number of ways of arranging. How much number? 7, 8, this one, 8, 1, 9, 1. Find the number of ways of distributing 10 apples, 5 mangoes, 4 oranges among 4 persons if each can receive any number of fruits and same type of fruits are identical. This is the question. Find the number of ways of distributing 10 apples, 5 mangoes, 4 oranges among 4 persons if each can receive any number of fruits and same type of fruits are identical. By using the Becker's formula, we can easily directly answer will get within 1 minute. But after or else doing the such cases we can draw. All are different, two types of identical, or else two identical, or two of them are identical, all are same identical. Sub cases we can draw. But in the short form, by using the Becker's method, easily formula that is n plus p minus 1 cp minus 1. What is the answer, Nana? Give the response. What is the answer? Question number 10 also I am writing. Find the number of ways in which 16 identical toys distributed among 3 students such that each receives not less than 3 toys. These dash. Two questions are given. Okay, find the number of ways of distributing 10 apples, 5 mangoes, 4 oranges among 4 persons if each can receive any number of fruits and same type of fruits are identical. Question number 10. Find the number of ways in which 16 identical things are distributed among 3 students such that each receives not less than 3 toys is dash. Here how many persons are? P equal to what? 4. So how many we have? 10 apples and then 5 mangoes and then 4 oranges. So by using the Becker's formula, 10 plus number of persons are 4. By using the 10 apples, that is 10 plus 4 minus 1, C 4 minus 1. This is the first option. And the second option is, next one is 5 plus 4 minus 1, C 4 minus 1. Next using the 4 oranges, then 4 plus 4 minus 1, C 4 minus 1. The answer is goes to 13C3 into 8C3 into 7C3. That's all. This is the answer. 10 apples per mangoes, 5 mangoes, 4 oranges. The total value is 13C3 into 8C3 into 7C3. Okay, next go to the question number 10. Find the number of ways in which 16 identical toys are distributed among 3 students such that each receives not less than 3 toys. What is the answer, Nana, for this 10th question? Number of ways in which 16 identical things are distributed, at least 3 toys. So S1 plus S2 plus S3 is equal to total numbers are 16. 3 students. 3 students means S1, S2, S3. Then goes to the 16 identical things we have. So this for 3 things. This for second student can 3 things, 3 things. So 3 into 3, 9. Remaining 16 minus 9 equal to 7. Therefore, remaining toys equal to 7. Therefore, by using the formula 7 plus 3 minus 1 C, 3 minus 1, which is it carries 9C2. This is the 9C2. Okay. Next question. Question number 10 or over 11. In a bakery, 4 biscuits are of type of are all available. How many ways Nitin can buy 10 biscuits if he decides to take at least one from each variety? Give the response, Nana. Answer, very easy answer. Options are 84, 85, 96, 126. What is the answer? So total things are here 4 biscuits. Total things are 10, and the number of among the persons are only 4 type of biscuits. Now how many biscuits can it at least one each of the variety? So that is B1 plus B2 plus B3 plus B4 equal to total value becomes to 10. So distributed at least one biscuit. So B1 biscuit 1, B2 that is 1, boy 3, so 1, and then so total 10 minus 4 that is equal to 6. So remaining things remaining things equal to 6. Therefore, by Beggar's formula, 6 plus 4 minus 1 C, 4 minus 1, that is equal to 9C3, that is 9 into 8 into 7 by 3 into 2 into 1. 3 3 is 9, 3 4 ja, that is equal to 84. So option is first option. Similar next question. The inequality n plus 1 C6 plus NC4 is greater than n plus 2 C5 minus NC5 holds true for all n if n is greater than dash. N is greater than equal to dash. So what are the values are given? First you take n plus 1 C6 plus NC4 is greater than n plus 2 C5 minus NC5. So minus NC5 bring this side. N plus 1 C6 plus NC4 plus NC5 is greater than n plus 2 C5. Now observe, this is the formula. What is the formula? NCR plus NCR minus 1 equal to n plus 1 CR. If the numbers n are same and the next denominator suffix r and r minus 1, write the bigger one value cr by adding n as to plus 1. So n plus 1 c6 plus n plus 1 ncr plus ncr minus 1, that is n plus 1 c5, which is greater than n plus 2 c5. Again it is in the form of n is same, that is n plus 1 same, and in the form of ncr plus ncr minus 1. In the place of n we have n plus 1. Therefore n plus 2 c5 is greater than n plus 5 c6, sorry, n plus n plus 2 c6 bigger number is 6 and n plus 2 c5. So now applying the formula is NCR equal to n factorial by n minus r factorial into r factorial. That is n plus 2 factorial divided by 6 factorial into n minus n plus 2 minus 4 factorial, which is greater than n plus 2 factorial by 5 factorial into n plus 2 minus 5 factorial. Now n plus 2 factorial cancellation. This can be written as 1 by 6 factorial into n minus 4 factorial is greater than 1 by 5 factorial into n minus 3 factorial. Then it is becomes 2. This can be written as 6 into 5 factorial. And then it is as to 1 by greater than n minus 4 factorial as it is. Then it is goes to 5 factorial into n minus 4 into n minus 3 into n minus 4 factorial. Then this will be cancelled, this will be cancelled. Then 1 by 6 is greater than 1 by n minus 3. So n minus 3 is greater than 6, n is greater than 9. That's all. This is the question number, a previous year question only. Next formula, number of ways to distributing n distinct objects among m persons is m to the power of n. When there is no conditions to be applied, so for this formula is m power n. So this formula can be remaining by hand pump formula. So m is fixed here, n is variable. So m can be always fixed, n is always variable. Okay. So that is basic formula. Example we can take. Number of ways, number of ways, 6 rings can be on 4 fingers of one hand is dash. So that is fixed is here 4 fingers are fixed and rings are variables. Therefore, ring, how many rings are there? One ring, second ring, third ring, fourth ring, fifth ring, and then sixth ring. This can be applied every ring as 4, 4, 4, and then this has to write as answer is goes to 4 power 6. By using this hand pump formula, why I am saying that M is fixed, fingers are fixed. So rings to be variable, it should be variable number. So the answer directly we can write as 4 power 6. Okay, in the same way, next question is there. Question number 2. In how many can you post? How many can you post 5 letters into 3-letter boxes? So what is the formula? Hand pump formula, fixed to variable. What is the fixed here? Post letter boxes is fixed. So answer is goes to 3 power 5. Don't get 5 cube. This is the fixed to variable. That is by saying the hand pump formula. Right? Don't get confused. Options will be given 5 cubed and 3 power 5, 4 power 8 and 8 power 4 given. So don't give the answer as to 5 cubed. By using fixed number down, I am raising the power as to 5. In the same way, third question is given. In how many 3 rings can be worn on 4 fingers if any number of rings can be worn on any finger? First one, rings are distinct. Second one, rings are identical. Two questions are given in this question. So rings are distinct mean by using the hand pump formula, ring 1, ring 2 and ring 3. Each ring can be into 4 rings. So answer is rings are variables, fingers are fixed, or else fixed to variable, that is hand pump formula. Then you get the answer is 4 cube. And similarly, second question, rings are identical means here rings equal to how many? Rings equal to n, that is equal to 3. Persons equal to how many persons? 4 persons. 4, not 4 fingers, 4 persons this is. Fingers nothing but we treat as here persons. Fingers only. So persons equal to 4. Then formula is Becker's formula n plus p cp minus 1. Then you get 3 plus 4 minus 1 c4 minus 1. That is 6 c3. That is equal to, you can get as 20. Distributed by a person. Persons are also different by union by using the identical things are given. Distributing, that is making to Becker's formula. But here the rings are distributed. Distinct are given. Distinct mean all are different. So it can be by using the hand pump form. Hand pump form means fixed to variable. Don't give the answer as to 3 power 4. What is the fixed? Fingers are fixed. So 4 power 3. That is giving the, don't get confused for this one. Okay, fingers are fixed means 4 to the power of 3. Not give the answer as to 3 power 4. So option will be given, but hand pump formula you can apply observe. If rings are identical means go to the Becker's formula. Okay. Tomorrow I will explain the remaining topics. Very okay. Practice on this. Okay, Nana. Right. Thank you.